Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on the Unit 4 group work. So I'm going to probably bust through this whole page first, in one video, and then do the second page on the second video. Okay, so here are the formulas that you guys are going to be given on your test, exactly like this, without any titles to tell you what the formulas are used for, and also it's not going to tell you what the variables are used for or what they mean. So you have to know all of that stuff on your own. The first couple of problems are admittedly kind of difficult. If you want to go back on your 4.1 worksheets, that we handed out in those packets, that might be a better place to kind of work on some recursive problems and then also work on some, putting together the sequence, the equation, the explicit rule, given, the numbers in the sequence. So maybe check some of those out first before you kind of judge what this is going to be about, because this would be like way more difficult than we'd ask you to do on a test, as often is the case with the group work problems. So I'm not afraid to point those out. The first one, however, is just a recursive problem, and here's how we list out the first 5 terms. The first term is already given to us. It's 3, that's A1. Now to find the second term, A2, it's when n is going to be equal to 2. Now, this is basically what's going to happen. Like, we're going to look for A2, so that's going to be this thing. And if A2 is the same as an plus 1, that means that 2 is the same as n plus 1. So what is our n value going to be equal to? It's going to be equal to 1, right? Because 1 plus 1 equals 2. So I'm just going to plug in 1 for n here and 1 for n over here. So I get 2 times A1 times 3 times 1 minus 1. And then, I'm not going to solve for the numbers just yet. Instead, what I'm going to do is put together the pattern so then I can see the pattern that's established with this. To find my third term, right, if 3 is equal to n plus 1, then that means that my n value is going to be equal to 2. So that means that if I use the rest of this formula, that means that it's 2 times A2 times 3 times 2 minus 1. Then to find the fourth term, A4, if 4 is equal to n plus 1, that means my n value is equal to 3. So if I plug that into the rest of it, I get 2 times A3 times parentheses 3 times n, which is 3, minus 1. And then finally, if I want to find A5, then 5 is equal to n plus 1, meaning that n is equal to 4. And if I plug that in the rest of the way, I get 2 times A sub 4 times parentheses 3 times 4 minus 1. Okay, so I really don't know anything yet about, what those numbers, A1, A2, A3, A4 are going to be to plug in to find the rest of them, but here's how I can start it. Because I know that A1, if I remember, is equal to 3. So this A1 that I have right here, I can just erase that, and it becomes a 3. So now these are just numbers that I can multiply together. 2 times 3 times 3 minus 1, so 2. And if I just multiply those together, 6 times 2 is 12. Okay, so 12 is my next term, A2. Now let's find A3. To find A3, we need to know A2, which we just found. It's 12. So I can replace this A2 with 12. So I get 2 times 12 times, 2 times 3 is 6. 6 minus 1 is 5. So 2 times 12 is 24. 24 times 5 is 240. No, it isn't. It's just 2 times 10. 2 times 5 is 10. 10 times 12 is 120. Sorry, I'm doing too much in my head. So that's 120. A4. So let's find the fourth term. To find the fourth term, we need the third term, which we just found. It's 120. So I'm going to replace that in there. 2 times 120. So this becomes 2 times 120 times 3 times 3 is 9. 9 minus 1 is 8. So 2 times 8 is 16. 16 times 12 is 96. No, it's 192. So add a 0, 1,920. So that's our next one, 1,920. Oh boy, this is jumping off. There's a lot of big numbers here. Now we got to plug that in for A4. There we go. So that's going to be a 1920. And then, this one I'm just going to use my calculator. All right, calculator. And it's 2 times 1920 times 12 minus 1 is 11. So times 11, and I get 42,240. So that's my fifth term. Once again, you can count on this one being a lot easier than the problem that we have on the group work. On the test, we're not going to have anything like that. It'll be a lot more straightforward. So don't worry too much about that. Next, find the formula for the nth term of the sequence. Hint, make the first term a fraction, and then note the pattern in the denominator. So I'm going to do that. The first term as a fraction would just be 1 over 1, and then I'd have 1 over 2. Then the next one, 2 over 3, and then 3 over 2, and then 24 over 5, and then 20. I'm going to make that one a fraction too, just because, whenever you see fractions in a sequence, just turn them all into fractions. It helps out in the long run. So I noticed that in the denominators, I have 1, 2, 3, and then 2, and then 5. Well, if this was a 4, I'd have 1, 2, 3, 4, 5. So let's see what happens with that. So if I change that to a 4, I'd double the bottom, then I'd have to double the top also. So this turns into a fraction of 6 over 4. And then 1, 2, 3 over 5. So if this is 6, I multiply the top and the bottom by 6, and I get the equivalent fraction 120 over 6. So here's the thing, okay? Like, I see this pattern immediately. This is the factorials. But if we just introduced factorials in this unit, so it's not like you should automatically see them and say like, oh yes, factorials, of course. We don't expect that. So, expect this problem to be a little bit easier than this, obviously, maybe patterns that you've seen before. But anyways, the bottom is just the same as the term number because this is the first term, second term, third term, fourth term, fifth term, sixth term. So it's just going to be equal to the n value, the term number. And the top part, 1 is 0 factorial, and this is 1 factorial, 2 factorial, 3 factorial, 4 factorial. I recognize these because I've seen them a bunch of times, 5 factorial. And each time it's the term number minus 1, so it's going to be n minus 1, and then factorial. I spent entirely too much time on number 1 and number 2. We wouldn't ask you guys to do problems like these on the test because, I know how to do these. They're easy to me because I've seen them a bunch of times. We wouldn't ask you guys to do these on tests because these would be a little bit more difficult for you. All right, next, using sigma notation. Use sigma notation to write up the sum, but don't find the sum. So this is going to be really easy. You just need to be able to, write out in sigma notation. So first we use the sigma symbol. Sigma means that we're adding all of the terms in a sequence together. The number that goes down here and the number that goes up here tell us just what sequence, what numbers from the sequence we're using. Let's assume that we're starting with the first number in the sequence, and that's 3. So let's say that n is equal to 1. That's the first term in our sequence. Then we have the first term, second term, third term, fourth term, fifth term. So we're adding up to the fifth term. So that's why the 5 goes up here, because we're looking at the fifth term. The part that goes over here is just the equation that the sequence represents. So if I go from 3 to 1 to negative 1 to negative 3 to negative 5, I'm just simply subtracting by 2 each time, which means that it's going to be arithmetic. And that means that I can use the arithmetic sequence over here. That's the explicit rule, and I'm just going to plug in those numbers. The common difference is what it keeps subtracting by, so that's 2. The first term, A1, is 3, so it's just going to be 3 plus my common difference, so that's going to be down 2, so minus 2. And then times n minus 1. And I can just leave it exactly like that. Now it's in sigma notation, and I'm all done. All right, so we've done the first 3 problems. It looks like I've already taken about 8 minutes of time on this video. I'm going to finish up these 2 and then start up another video so it's not too lengthy. All right, so for number 4, find the sum, show all the work. This is sigma notation, so we're just going to be taking a sum. We start off with the third term, we end with the 7th term. So in other words, we're plugging in 3, we're plugging in 4, we're going to plug in 5, we're going to plug in 6, and we're going to plug in 7, and that's when we're going to stop because it tells us to stop at 7. So we're going to use this equation to find each of these terms. So if I plug in 3, 3 squared is 9, 9 times 3 is 27, so 27 on the top. 3 plus 1 is 4, so 4 on the bottom. Now let's find the 4th term. So we plug in 4. 4 squared is 16. 16 times 3 is 48. 4 plus 1 is 5, so 5. Now let's plug in 5. 5 squared is 25. 25 times 3 is 75. 5 plus 1 is 6. If we plug in 6, 6 squared is 36. 36 times 3 is 108. 6 plus 1 is 7. 7 squared is 49. 49 times 3 is 147. And and then 7 plus 1 is 8. So if we just simply add all of these numbers together, we get our summation. So let's see here. 27 fourths plus 48 fifths plus 75 sixths plus 108 sevenths plus 147 eighths. And we get some decimal. So let's convert that to a fraction. So let's see here, fraction into decimal. All right, so that's a, let's see here, 62 times 280 plus 183. Oh gosh, this is why I should use my other calculator. I'll just use this one real quick. Or no, I'll just multiply it out. But like, so here's the reduced fraction. It'd be 62 times, oops, what did I get there? It's, I'll just do this calculator. Sorry I'm so indecisive about it. I just didn't want to waste too much time. I ended up wasting about a minute. So I'm going to add up these fractions, 27 fourths, one more time, plus 48 fifths, plus 75 sixths, plus 108 over 7, plus 147 over 8. And then turn it to a fraction. There we go. That's better. So I get 17,543 over 280. That's what I was looking for. That's my summation right there. That's what all of them add up to. Okay, and now for the last one that we have is, it has an infinity at the top of the sigma sign, so that means it's an infinite sequence, and this is a geometric sequence. I mean, infinite series, so this is a geometric series, and it's going to be infinite, so that means that we can use this formula right over here, so long as our common ratio, R, is between, its absolute value is in between 0 and 1. As long as that's the case, then we can use this formula. It converges. If it doesn't, do that, if it's not between those numbers, in other words, if the R value is greater than 1, then it's going to diverge and not get a single value that it adds up to. So luckily our common ratio, R, is equal to 1/2, and that is indeed between 1 and 0. So that means that we can use this formula, and it's really easy to use it. The sum is equal to the very first term on our series over 1 minus our common ratio. The very first term in our series is found by plugging in 0. So if I plug in 0, 10 to the power of 1/2 to the 0, so that's going to be 10 times 1, which is just simply 10. So 10 is the number that goes on top there. It's the first number in our series, over 1 minus our common ratio, which is 1/2. So this turns into, let's see here, 10 over 1 minus 1/2 is 1/2, and 10 over 1/2 is just equal to 20. So there's our answer for that one. And yeah, I'm going to stop there for this video. This one's already gone a little bit long. And then we'll move on to probably number 5, 6, 7, and 8 for the next video after that. Okay, till then.